Hello everyone and thank you very much for watching. This is me, Mr. P, and this is another episode of Proxmox Home Server series. In this video, I'll show you how you can self-host Octoprint instant inside your Proxmox host and how you can run Docker container with a Prusa Slicer inside it. So let's begin. First of all, we're going to start by setting up Octoprint. I do have a Dietpi template here that I will use to host Octoprint. I chosen Dietpi for main reason that Dietpi OS comes with this feature called Dietpi software, where you can search for software out of like hundreds and hundreds of them, and you just pick which one you want to install, and it's already have all the code required to install Octoprint, so you don't need to type a lot of code, just to choose the Octoprint from a list, bam, and it's installed, and it's going to be work fine. Obviously, everything what I'm showing in this video, you can sort of start from scratch, setting up Ubuntu server, virtual machine, or container, and set everything up. But this one I found it much easier to do, and it's just user-friendly, and it's going to be running in no time. So let's start by right-click on the Dietpi and choose clone, because I want to clone into a different VM. I will name this 3D printing -YT, for example. I'll choose the location where I want to store virtual drive. In my case, it's going to be local. Your location of where you're going to store virtual drive might be different depending on your Proxmox setup. So I'm just going to say clone, and it's cloning the VM. VM is cloned, and I will not start this VM yet because we need to do a couple of more changes. First of all, I want this one to be actually changed from template. Actually, we're going to remove this. Not going to say there's a template. Right, okay, let's go to hardware. First thing, 2 GB of RAM is okay to run Octoprint and the Prusa Slicer inside it, but I recommend to increase that to 4 GB and actually do with a Boolean device activated. So let's do this for 4096, which is 4 GB, and 2048, which represents 2 GB RAM, so it's going to fluctuate between 2 and 4 GB of RAM. Next thing, 1 core is not enough. 2 core is minimum. 4 core is probably the better. I'll choose 2 cores. I know it's going to work fine, but I suggest to increase a bit to 4 if you're planning to do a lot of printing, and your Proxmox host will do a lot of stuff besides running Octoprint, because you want this VM to run as fast as possibly can, because it's going to send data to a 3D printer while it's printing. Next thing what we need to do is actually get ourselves a printer connected to this virtual machine. To do that, my printer here on this side, Ender3-S1, is wired with a USB cable connected to a Proxmox server, which is on this side. So I have like, I think, 5 meter length USB type A to USB type C cable. USB type A connected to this side, and USB type C connected to the 3D printer, and 3D printer is on. And when this 3D printer is on, my Proxmox detects that this 3D printer is connected. I can verify that going into a Proxmox node, and the shell, if I write ls USB, so list USB devices, I should show up here. This is the one. Qingen Electronics, this is the one. Let's say you have a big list of this stuff and you don't know which one is which. I suggest to turn off the 3D printer, check the ls USB, all the list of the stuff, take a screenshot of that, then turn the 3D printer back on and get the list again and just spot the difference. Check what's appeared that wasn't in the first screenshot, now it's showing in the second screenshot. But I know this is 1A86 because this 3D printer being connected to so many VMs, I already recognize the vendor ID number straight away. So I know that the 3D print is being detected. I'll go back into my 3D printing VM under hardware, I click add, and choose USB. Put the bubble next to USB, a vendor's device ID, and I'll choose USB serial. This is the one, as you can see, 1A86:7523. I'm going to click add. And right now I am passed through the USB device, which is 3D printer, which is connected to a Proxmox, into this virtual machine. And now I can go and click console and press run. So I'm going to run this just to get the IP address, because remaining stuff I'm just going to go and do via SSH client, because it's going to be much easier for me to increase the font and easier will be for you to read. So I'm just waiting for IP to show up. So it's 142. I'll open the SSH client and do SSH root 192.168.178.142. And yep. My password. So how to get Dietpi OS VM create inside the Proxmox. I already did the tutorial. I think it's maybe first or second episode in this series. I leave a link in the description below for you to go and check it out, how you can do what is the process to get Dietpi VM running inside the Proxmox. It's super easy. In total, I think it's maybe 3 commands, maybe 4 commands. I mean, you can do this in less than 5 minutes. I've done Dietpi OS setup so many times that I can just speed run this for like a minute and a half or something. Obviously, it all depends on internet speed because you're going to have to download Dietpi OS image, but you can speed run through this in like 2 minutes or less. So this is the Octoprint VM. So LS USB inside here. I should be able to see the same one show up here. So it means that this Linux instance, which is Dietpi OS virtualized inside Proxmox, detects the printer. So basically for this VM, it's like the printer is directly connected into that VM, so all works fine. So next thing, what I suggest to do is just do a quick update and upgrade. So apt update, just run a quick update before installing Octoprint, just to make sure everything is up to date and upgraded. So we're just gonna run apt update, apt upgrade, okay. And now the fun part, installing Octoprint. To do that, you need to type dietpi-software, press enter, navigate to this option, which says software, search software, find software to install via search box. If I click browse, if I choose browse software, you can see this is how many of the stuff you can install just using just a one tap, click, go, and it's done. So we're gonna use search. I'm gonna write Octo and press space to put asterisk to select that, then confirm. Go all the way down to install, press enter, then select OK, press enter, and just leave out Dietpi OS to do the rest of the stuff. It's going to automatically download all the required packages, update them, upgrade them, and install Octoprint for you. So I'll be back when all this is done. And here we are, in less like a 40 seconds or less, I think it's less than 40 seconds, Octoprint is installed. To verify that Octoprint is running, I need to type dietpi-services, press enter. And as you can see at the top, it says Octoprint enabled. This Octoprint might show up somewhere in this list, but as long as it says Octoprint enabled, and it means it's all good and running. Octoprint is installed and my IP address is 142 or ending in 142. Let's go back in the browser and enter the IP address, my local IP address, which in my case is 192.168.178.1.142, semicolon 5001. Press enter. And if everything is fine, I should see this. This is the Octoprint initial setup. So let's quickly go through this. I'm going to click next on here. Restore from the backup. If you have an Octoprint running somewhere else, you can export the backup and import it here to restore all the settings. And click next. Create a user. So I'm just going to do something simple. Here we go, Mr. P, and then password. Okay, create. That's fine. Don't remember this. Click next. Now it's asking you to do a quick check on the network. I'm just going to say test the host. So server is reachable. So it means it detects the Cloudflare. And is DNS works fine, resolver works fine, great. Enable connectivity check. This will allow Octoprint to frequently, I think it's every 5 minutes or so, check the internet connection just in case if something goes wrong, because Octoprint will do updates automatically. What I mean by that, it will download the updates, or you will get a notification that the update is pending, that you then can initiate the update when it's not printing, because updates, or after the updates is downloaded and installed, Octoprint will have to restart. It's not the VM will restart, but Octoprint services will restart, which might interfere with the printing that you're doing at that moment. So next on that, anonymous usage, I'm going to say yes, I don't mind to send an anonymous usage data to the Octoprint team for them to make this product even better. So I'm happy with that. And the next, I'm going to say enable plugin blacklist process. That means that it will check if you installing a plugin that is legit. It's not like something like a malware or something else that might basically create a backdoor to your server. So I definitely wanted that to be on. Next, then if you want to add the stream URL or add the webcam, if for example you have a Motion Eye set up on this different VM, you can set up a streaming and etc. I'll show that in the upcoming videos. Next, name, I will name it Ender, and model is Ender3-S1. You can put whatever you want. I just want this to add it just in case for the logs if I want to troubleshoot in the future. And click next. That's it. It says all done. So click finish. So that's it. This is Octoprint. A couple options here and etc. for me to mess around. So right now it's not connected to my 3D printer. I'm just gonna turn this on, save connection settings, and auto connect on the server startup. Basically, that means that your printer is on, and then you start this VM with Octoprint. Octoprint automatically starts and tries to connect to the printer. So I'm going to click connect. And right now I get the message saying that printer firmware support host and etc. But that is disabled. I'm fine with that. I'm going to click disable firmware check. And now if I click on this, and this is the controls that I can use to control the 3D printer. So right now I'm going to show you from the camera you can see, but this is there where the horizontal axis right now sits. So I'm going to press down is going down by 5 millimeters. By 10 millimeters, that's fine. Let's wait for a bit more, click down again. So I'm controlling my 3D printer from this VM. So Octoprint is all happy and running. So if you have already the G-code file ready, you can press upload, select the file, upload, and it's going to start printing in no time. So Octoprint is set up, but what if you want to have a slicer as well running on top of it? So that's what we're going to do now. We can set up a slicer. You can set up the slicer to be hosted in the same VM as the Octoprint, or you can create a separate one. In my main Proxmox, I have a VM that is only dedicated to Octoprint, and then I have a container which is only dedicated to a slicer. And I done this way because I don't want to basically keep all the eggs in one basket, if you know what I mean. But there's still all the eggs in one basket because all the services runs on one single node, Proxmox node. But with the kind of virtualization, I like to split the services, even if it's not the best efficient practice. Because let's say 3 weeks from now, I will decide to bin the Prusa Slicer and I want to host Cura Slicer. That's all I need. You just stop this LXC container, swap it with a Cura container, and everything is running. So in this video, I'll show you how I can host inside same VM as Octoprint. But like I said, you can host it on a separate VM, separate control. It can be even on a separate device, as long as they both can see each other via network. So let's go back inside the terminal, inside the Dietpi. Now what we need to do is navigate to a folder which is called /mnt Dietpi_user_data. Inside here, I will create a folder called Prusa. We're going to use Prusa Slicer, but the same thing, and you can find a Docker image container thing for the Cura Slicer as well. I just started to use Prusa Slicer because it just, the prints happening faster when the STL file is sliced. This is basically what is slicer. We're using a Prusa than a Cura container. So your preference may vary, but I'm using Prusa. So let's change to folder Prusa folder. So inside here, we need to create 2 folders and 1 file. First folder will be prints, and another folder will be configx. And then we need to add a file, which is called, I'm going to put docker-compose.yml. I already have a Docker Composer and Docker installed from my previous video for the Dietpi OS template setup. But basically, this is, again, very simple to install. If you go to Dietpi software, you just go to search for software, just type Docker, and here we go. You select these two, 134 and 162. Click confirm, then click install, and the Dietpi OS will do the rest. So I have right now 2 folders and a file. So let's edit the file. And inside here, I'm just going to copy the Docker instructions, and I'll give you a quick rundown exactly what all this is. So right now, this instruction states, as we're going to use a version 3 for this Docker Composer, we're going to create a service, which is called Prusa Slicer-novnc. We're going to use Mike's image, mikeah/Prusa Slicer. So this is the location inside Docker Hub, which image to use. We're not going to put anything at the end. Most of the times when you're using Docker, you might find something here like latest or let's say stable or something. If you put nothing, it's always defaults to the semicolon latest. So we don't need to put that. Container name is going to be Prusa Slicer-novnc. We can rename this just to Prusa Slicer. User 00, I'm going to give permissions to root. This is not the most secure way to do, but it's most easiest way to make sure that there is no confusion between the read and write permissions, because root has read and write permissions on everything. But if, for example, I'll use like this 1000, I need to make sure that the files and folders and everything has a decent permission. But I'm running this inside my home lab with no access from outside internet yet. This video is coming. This is going to be fine. Just use 00. You obviously can put 1000 and to figure out your permissions and the read and write permissions, etc. Port is going to be 8080 outside and 8080 inside the Docker container. And this is where the configs will live. Configs, that's not supposed to say config, that's supposed to say configs. And then prints. Prints is where we're going to store STL files, and configs is basically that's what Docker will store. Docker container will store these settings to persistent storage. So the file is ready. So right now what I need to do is to get this file saved and ready to go. Control X to close, Y to save, Enter to confirm. And now we are ready to run this Docker container. To run Docker container using Docker Composer instructions, inside the folder where you have Docker Compose file with instructions. So if I just do quickly like this, So I export the file. As you can see, this is all the instructions. I want to make sure that config's here, prints here, everything is here. So right now we can start doing this thing. So to run Docker-Compose, we're just going to run like this and press enter. And right now Docker will start Docker container using Docker-Compose instructions. First it's going to go and pull all the container in the chunks, as you can see here on the screen. Once they download it, they will be extracted. Once they extracted, Docker will try to run the container. This is where their 4 GB RAM is very useful to have, because while it's downloading, we can quickly go here and see the performance. So as you can see, we're doing almost 2 GB of RAM. It's actually increasing. Here you go, it's going to be over 20% is used. If you only selected 2 GB of RAM, the Docker pull or Docker extract and everything will start to stagnate, and it's going to become slower and slower at the end. So I'm going to leave this run, and I'll come back when the Docker container is running. Here we are, we have a Docker container running. So I'm going to do docker-space ps. It outputs the file, the output for the Docker and what kind of container is running. Is a bit of the weird formatting. So let me quickly try to do this way. So what that shows, it shows me a Docker container ID number, the Docker image. The command that's been used to initiate that is created 33 seconds ago, is been up 30 seconds ago. The ports that is out, the exposed to a host. Then it's the last bit is basically a name, Prusa Slicer. So we used port 8080 to access this container. So we'll go back in the browser, open a new tab, and my IP address one was 142. So if I punch this in, my IP address 142, semicolon 8080, press enter, click connect. And this is the SSL certificate, so I'm just going to say remember my choice and click yes. That's it. We have a Prusa Slicer running inside the container. So let's do a quick setup. First of all, I'm going to click next. I'm not using any Prusa printer, so I'm going to say none. And I will go and select custom printer. Other vendors, sorry. Click other vendors. I'm using a Creality Ender3-S1, so I'm going to tick Creality. Then click Creality FFF. Click none, because it's going to be one of the printers will be automatically selected. I'm just going to click none, and I'll find my Creality Ender3-S1 printer. So the nozzle size that right now my printer has is 0.6. You need to choose between 0.4, 0.3, or 0.5 depending on your setup. I know mine is 0.6. You need to make sure that you select the correct nozzle, otherwise the printer or prints will end up being really, really bad. So click next on that. I don't need anything here. Click next. Right now, what kind of the filament I'm using, I'm going to say none, and I'm just going to go and say PLA, and I'm just going to use generic. Obviously, if you're buying a specific brand, you select the brand from here. If it's not here in listed, you just select generic. So I'm using generic PLA, and I know I'm using generic PETG to print. Actually, I do have a TPU as well, but we're not going to add that in at this moment. Click next. Check for updates and etc. Leave everything by default. Allow built-in downloader, that's fine. Export, that's fine. And I want expert mode. That means all the settings for the slicer will show up. Otherwise, it will do simple. It's just basically gonna hold your hand for all the setup. I'm just gonna say show me everything. If your setup requires use inches instead of millimeters, you can activate this one here. Click finish. So now it's going downloading all the stuff, and here we go. This is my 3D printer. Sorry, this is my Prusa Slicer. So right now I have the options, which kind of size, the layer height I need to print, what kind of filament I'm using, and what printer I'm using. Right now it's set up as a Creality Ender3-S1, but this slicer know nothing about this printer and Octoprint running. So we need to get that going. First thing, I'm going to go in Octoprint, click on the wrench, and we'll go to API, select API, copy this code. I'm just going to click this a couple of times to make sure it's definitely copied. Go back in here, and now we can go and start setting up. So we're going to go under printer settings. We're going to click, make sure that this is selected, click on the cog, and it's going to say host type Octoprint, IP address 192.168.178.142, semicolon 5501, and this is where I need to put my IP key. I'll click on this icon here, which will expand this. Click on the paste bin or on a clipboard, paste the code in, delete all that because I don't need this. Just make sure it's all in, because I can't just directly paste into this slicer. I need to go via the clipboard. So this is pasted in here. So right now, if I move this window to here, I can right click and paste in here. As you can see, it's pasted in. Let's close that in. Let's do a test. Connection to Octoprint works correctly. That means that the Prusa Slicer detected Octoprint, which is connected to a 3D printer. So this is all good. I'm going to click OK. And click, I need to name this. So I'm going to call this, let's delete all this. I'm going to call it Octi. Close it. And that's it. And right now it sits here. So if I go to my platter, and now I'm setting up what I want to print, I can choose between the Creality-free and Ender3, which is like a base setup. But actually I need to make sure that it's selected Octoprint, and now I can start printing it. So we're going to close this. So right now, how to get the STL files into this slicer? Well, because we're running Dietpi OS. Dietpi OS has a very useful feature, or like I said, Dietpi Software Center, where I can easily install stuff. So if I go back to here, I'll double check if it's installed or not. I'm going to click on Search Software, write Samba, and I need to install Samba Server. I'm going to click OK, install, and let Dietpi OS install my Samba Server, which I will use to mount the prints folder to my laptop, and I can just move STL files directly to it. So I have Samba installed. To double check that Samba is working, I write Dietpi-services, and I can see SMB is enabled and running. So I can right now mount Samba Share to my laptop. We're going to do this now. I'm going to open the file browser. I'm just going to quickly mount off screen because I don't want stuff showing up. Here we go. So here we go. I'm going into an SMB IP address 142, ending with 142. Click inside here, asking me to mount it. I'm going to say registered user. We'll give this a name, which is Dietpi, and the password is going to be the one I'm using. Remember forever. Click OK. And this is the folder content. All this is literally exactly what you see once you log in. And one of the folders should be Prusa. And here we go. We have our Docker-Compose file. We have prints and we have configx. Inside the prints, I'm just going to go and fetch one STL file to drop that in here. So this is going to be, let me quickly find it, this one. So drop in. So it says gas key part 2 STL. Right now, if I go back here and I will load the Prusa Slicer. Okay, it's not loading. Let me check what's wrong with it. Let's have a quick look. Minty.py user data, cd Prusa, just a quick troubleshoot. Oh, one thing I missed on here. You need to add one more line here. Restart, semicolon, unless stopped. Okay, this is what I need to add. The compose instructions inside the below the like in description section will be correct. It just I missed that one on this thing. So right now I can run docker-compose /up-d and run that. There's no need to re-download the packages or anything because that's already in. So it's just running a container. So let's go back and restart. Don't say anonymous things. So everything is here. As you can see, this is my setup, the Prusa and Octoprint here. So right now, if I'm going to click on the plus sign, go on the prints, this is the key, the STL file uploaded by SMB, click open. And this is the key that I designed inside Onshape to open my gas and electricity utility box. So right now I can press slice, and it's going to tell me that it's going to take 1 hour to print. This is not the right thing because it's 0.08. I want to do this one, which is going to be chunky speed. Click this. There we go. And this is going to take 27 minutes. That's fine. Let's make sure if I click on this G icon, which you should see on the screen, and it's going to say, do you want to send this? Upload and print. I press that. And printer should start printing. Here we go. Octoprint detected that it's been uploaded. As you can see, the file showed up here. I can hear the printer temperature going up. According to this graph, as you can see, it needs to reach 150 for the start, and then it's going to reach 205 for the printing. And the bed temperature is going to be at the start, I think it's 50. Oh no, it's going to jump to 60, as you can see here, 60 and 150. So 3D printer right now is going to start printing this key. I can see 3D printer is moving, getting homing X, Y, and Z axis to make sure that it's all home to a right spot, 0, 0, 0, and then it's going to start printing. Here we go. I have the Octoprint VM running in my Proxmox instance. And the summary, let's see how it's performing. So it's doing over 1 GB of RAM usage. RAM is very important inside the Proxmox VMs. So 4 GB, like I said, is minimum, and 2-core CPU. You might drop this to 1, but 2 and 4 is probably the best one to go for. And right now, 3D printer is going to go and 3D print one of these. which I did earlier. Actually, I printed 2 because I keep losing them. And when I need to go and check the electricity meter or gas meter, I need one of these keys. I can't find the metal one, so why not? I went and designed one of them to be printed. Here we go. I have Octoprint virtual machine running in my Proxmox with a Prusa Slicer attached to it. There's a couple of more things you can add as a bonus. Let's say for your homework kind of thing, you can create yourself a virtual machine of motion eye, attach USB camera, like I did here. I'm not sure if you can see that, but there's a camera here. And then you can pass through USB camera into a VM, which runs motion eye. Then you can copy the stream URL, which should be 9081 or 9091 port. Then you can plonk that inside, going here, going under classic webcams. Just paste that in here, and you will be able to see what the webcam is seeing, and that means you will be able to monitor your 3D printing. Again, as a bonus for this VM and kind of setup, if you watch my previous video about Cloudflare Tunnel, you can set up a Cloudflare Tunnel to access this instance of Octoprint and Prusa Slicer from anywhere in the world using domain, like for example, prusaslicer.vmrp.co.uk, and we're going to be with 2FA authentication. That means only me who can get access, because I will get the email to confirm that it's me. I'll get the temporary PIN code to access this. I can be somewhere else across the globe, on another country, another continent, even on another planet, as long as there is internet. And I can monitor exactly what's happening here with the webcam stream. Like I said, if you have a motion eye setup, and I can set this up, all this printing. And right now, 3D printer, I'm not sure if you can see, the camera is a bit, let's move this way. 3D printer is going and it's printing right now. Another gas gear knocked the camera down. Anyway, thank you very much for watching. I hope you enjoyed this video, and I'll see you in the next one. Goodbye.